Hello friends, in this video we will talk about LangChain's vector database. So vector database is not a concept of LangChain, but we will see the code in terms of LangChain framework. And we will also discuss about what is vector database and how it is storing embeddings. We will see actually how the embeddings look like. So stay tuned, we will meet after a short intro. So let's discuss about vector databases. In your childhood, I'm sure you might have heard about vectors in your physics. And do you remember what the physics says about vectors? It was a quantity which has its own weight, magnitude basically, and some direction. And in computer science, when we talk about NLP, it is also having this is two dimensions of a vector. Let's go to the screen and try to understand how the vectors and the space looks like. So let's build two-dimensional space x and y. And let's say if I put a point here and says x1 and y1 value of these two, then it means on the x-axis it has a projection of x1 and on the y-axis it has a projection of y1, right? But the same diagram if we make in 3 dimension, that means we are increasing the dimensions. And then it will have, let's say this is x, this is y, and this is z-axis. This point has the coordinate of x1, y1 and z1. Then in this case, its projection on x-axis is x1, on y is y1, and on the z-axis, basically this is z1, right? Similarly, if we increase to 4 dimension, which we can't draw in here, but if you can imagine, there is a 4-dimension space. Let me give you an example how you can think of a 4 dimensions. So in the real world, right, we have a 3 dimension. We can go right, left and up and down, right? These are 3 dimension. But let's say the 4 dimension is our time. Take an example. You have taken one rose and in the morning the rose is very good, it is flourishing and there is no wrinkles on the flower, it is very blossoming, right? But during the evening time, that same flower which was blossoming in the morning, in the evening it become dull, right? There was wrinkles, flower has lost its smell as well if it is broken, definitely, and then it loses its own characteristics. So with time things are changing, right? So that can be think of as a 4-dimension space. But beyond that, I even can't imagine like how we can think of 5 dimension, 6 dimension in real world. But definitely consider yourself, you as a human being have a different dimension. You have, let's say, some knowledge in your science, some knowledge in other aspects. As a human being you have 1 dimension, in your family you behave in certain way, so that's in another dimension. But when you deal with public, there is an another dimension, right? So as a human being you can think of you have a multiple dimensions. Similarly, if a vector is drawn in n-dimensional space, right, then how many points it will have? It will have x1, let's say x is the thing, x1, x2, x3, x4 till xn, right? This tuple is basically is your vector which has different shadows on different dimensions. x1 is on the first dimension, on the second dimension x2. Similarly in xn you have xn is the nth dimension. And now why I have brought you to your high school level and try to understand these dimensions in the vectors, it is because even in machine learning and computer science, these vectors are nothing just which have some magnitude and some direction. So in an n dimension space, if every vector, let's say in every dimension, that projection is 1, right, but its direction can be different. With the change in the direction, your vectors will change, and some of the value can be on the +1 and other value can be on the -1, right? Their magnitude will be same, but direction is changing. That's why the vector is different and it's changed characteristics. Let's see how we can imagine this thing on a 2-dimensional space or n-dimensional space. So let's say this is a 3-dimensional space and here we have one vector, and in your natural language, let's say there is a king, right, and that king has, let's say, some dimension, its value is x1, x2, x3. It's the 3-dimensional, so 3 vectors. Now the queen, so queen also has some characteristics which is similar to king. They are both powerful, they are both belong to the royal family, they they can do, they have lots of money, right, lots of power, but there is a small difference between these two, that is of gender. Queen will be female and king will be male. So if I try to imagine these two vectors, the most of the tuples will be of closer values. Only one dimension it is drastically changing, because let's say in one dimension, if let's say x3 is representing about the gender, then on queen it can be, let's say, 1, on in case of king the value can be -1. It's completely different. But whereas on other dimension, for example, on the dimension of power, let's say x1 belongs to power, so they have the both equal powers or almost equal. Let's say king is ruling, so it has more power, let's say 0.9, and then queen may have, let's say, 0.85, right, because these two values are closer because both have the huge power. Similarly, both belongs to the royal family, so if x2 representing the royal family, this particular position in the vector, then both will be 1, right? So this is how vectors works. So the two words or two entities which are almost similar will have the same tuples values, and wherever there is a difference, and then the difference will reflect in the values of those tuples. So this was a very simplistic understanding of the vectors in vector database. Now in large language models, right, when we are creating vectors so that we can build the application based on RAG approach, basically a retrieval augmented generation. In simple terms, if I try to make you understand about RAG, then it means we are providing some context to the LLM, right, and that context can be anything, your proprietary information, or let's say it's not proprietary but particular to the question that we want to provide some specific information, so that LLMs can help us to build a better reasoning engine and try to take that new information that we are providing apart from the information which it has from the internet and from the data on which it was trained basically. So now let's go to the code and see how the vectors look like, right? So in the program, what we will do, we will write the small program, and we will be using the ChromaDB, which is a vector DB, and it is persistent on the local machine, and there are different variants of that client that we can create of ChromaDB, and we can persist on the cloud, or we can persist on HTTP server based, where all the data will be hosted somewhere. And ChromaDB is one such a type of vector database, and there are multiple types of vectors DB which is coming right now. When there is an applications which are building using the large language models like ChatGPT and Gemini. So let's see and the code, and we'll talk about how the actual vectors will look like. And by the way, we will be using OpenAI for creating embeddings. So one more point I want to convey here. Embeddings are related to some particular model. So for example, if we have trained a model, we are creating our own large language model, then our embedding will be different from others model embeddings. Why it is so? Because when we are training the model, we are providing a lot of words and text basically to the model, right? And that model will try to create one n dimensional space, and that n can be in the training process. Basically, when we are designing the architecture of large language model, we will define there what are the dimensions that we want to keep for the vectors. So if you got a vector from, let's say, OpenAI, then that vector will not work for Gemini or for your local hosted LLM. So this we have to keep in mind. And right now there are multiple LLMs which are there, right? So the vectors of two different LLM will be different, but within the single LLM, the embeddings which are created using the same model will be same if for the two given words and sentences, but for the same types of words, the vectors will be similar because they are lying in the same vicinity. So let's see the code and we'll deep dive there. So as you can see, I'm using the LangChain and OpenAI for the model. So here I have done all the imports and then loading the OpenAI key in from the env file. So what I have done, I have created a GenAI text, the small text file, which is writing about what is generative AI and all. So we are loading this text file and splitting it into the small chunks of 1000 words, right, and without overlapping. I will talk about more in these splitters later in the series. Here what we are doing, we have chunked all the data that we have loaded from GenAI text file, and now from here what we are doing, we have created the small documents, and now through these documents we are loading these documents in the ChromaDB, and we are providing OpenAI embedding. So basically this is the embedding model which is coming from OpenAI, and we are creating a file here of ChromaDB, and you can see because this is persisting on the local device, so we will show what are the embeddings looks like and what are the different data that it is storing, and then based on that, like, we are asking one question, how GenAI can help in images, and then we are finding this thing. So here this query will be generated again to a vector, and then we are doing some similarity search. Based on that, it will return all the documents which are similar. And here what we have done, we have created a embedding vector and printed that so that you can see how the vectors looks like, right? Let's run this code. Here I am running our Python file, and you will see a folder of ChromaDB is got created. So, and it is SQLite based. So let me open this. So I have installed one SQLite plugin in the VS Code which can show all the data that is there. So let me see these things. So you can see there are multiple tables which are there in this SQLite, and it is storing those vectors. And here if you see embeddings, it shows embedding ID, sequence ID, and at what time it is created, and what are the different data which is embedded, that's also present. And let me open that. Yeah, here you can see in the embedding queue there is a metadata which is also stored, and if you see this, so it mentions the source from where it was created, and this is useful when you have lots of files and lots of context that you want to provide. So it will maintain those sources, and you can use these sources when you are generating some response to validate or to give some references. This will help you so that your data can be authenticated by the user. Here the vectors are created, and vectors is of 6 KB, and if you see what are the dimensions, so now here we can see the dimension in one of the table. Yeah, so this is OpenAI embeddings, and it has a dimension of 1536 tuples, these vectors in a tuple. So if I open terminal, you can see I have printed the vector, right? So this is a vector, and this has a dimension of 1536, and there are these such values, right? So your text, whatever it is embedded in this these numbers, and now these numbers will help us to find similarity search in the DB, or even these vectors when passed to LLMs. Then LLMs is also working on these this concept of vectors, right? So all these are based on machine learning and deep learning that got created when we were training the model. So this is all about vectors and vector databases. As you have seen how the vectors looks like actually in your code, and we don't have to deal with these vectors and these numbers. We will just, this I have shown you so that you can understand how the data will be stored. Now that database can be anything. Here we have used Chroma, somebody can use Pinecone, other can use MongoDB. So MongoDB also provide a vector database, a vector version, and LangChain as a framework provides so many supports for so many databases, and you can code just like we have seen the code here. We can take the client of any type of database and store our embeddings, our embedding of the context that we want to use in our application. So I hope you like the video, you have understood the concept of vectors, you have seen and become familiar how the vectors look like. And when we do similarity search, you can think of, okay, there are two vectors and we are trying to find the similar part of it or the distance between them two. So all that calculation is done through the vectors. In other part of the series, we will create other videos for creating any LLM based application using the LangChain. So we will talk about the split text splitter that we have used in this code as well, but we didn't cover much. We will cover in the subsequent videos. So if you like this video, please give a thumbs up so that it will be motivating for me to create more videos and more and provide more such knowledge. Please let me know in the comment section if you have any question. I'll be more than happy to answer. And if you are building any LLM based application, please do let me know in the comment section. I can help you with the development of that. I'm excited about how you are using vector databases in your application. And let's meet in our next video. Till then, bye. This is BK from Manekka signing off.